Hello, chemists. This is Jolly again. This video is going to be on the nomenclature of stereoisomers. So I'm again going back to the handout. All right, and it's not very long here, but we've already learned cis and trans, and remember those only really should be used for alkenes and some cyclic alkanes. So we're going to learn something called the Cahn-Ingold-Prelog system. And right there. So that's the Cahn-Ingold-Prelog system. Now I need to stress this is not the priority of functional groups. This is just a system to tell us, if you will, the rotation. All right. So the first thing we're going to do is we have to assign a priority to every piece on a stereogenic, and stereogenic means stereocenter, based on its atomic number. And that's the key. This is not functional group priority. It's literally based on the periodic table. And then we're going to go from 1 to 4 because there's 4 different groups. And isotopes we're not really going to play with, but we would go with the greatest mass if that was an issue. All right. B, if the priority can't be assigned directly, okay, you step your way out, okay? First point of difference. All right, so we're going to step our way out. So an alkene or a carbon-carbon double bond would really look like this. Now, I know that's not really its structure, but you can kind of visualize if I broke that double bond, that's kind of what I'm implying. Same as a triple bond. And then we're going to rotate the molecule. So either the lowest priority is away from you, or I'll show you a shortcut if it's directly at you. And then we're going to assign those groups. If they go clockwise, we're going to call it R. And if they go counterclockwise, we are going to call it S. All right, there's the basics. Let's jump over to the whiteboard and do some. All right, so first of all, we have to identify the stereocenter. Very boring molecule that I use all the time. All right, so this is 2-chlorobutane. Okay, so that's the naming that we've done in the past. But if it has any kind of a stereocenter, we need to put some stereochemistry in the name. All right, so let's go, and I'm not numbering the carbons here. I'm only looking at the stereocenter. Highlight that. I'm only looking right here. All right, so I am seeing a chlorine, a hydrogen, a CH3, and a CH2, CH3. Okay, so those are the groups. Based on those, don't go any further than that carbon. I'm seeing a chlorine, a hydrogen, a carbon, and a carbon. Well, hydrogen only has an atomic number of 1, so it's the lowest. And of course, chlorine has an atomic number of 17. I was looking at the periodic table. All right, so that is number 1. So I will put that there, and I will put that there. But I can't determine which of those 2 carbons should go next. So I can't determine one away, so now I need to go further out. This carbon is connected to hydrogens, which have an atomic number of 1, where this one is attached to another carbon and hydrogens. And so this one is going to take priority. So this one's going to be 2, and this one is going to be 3. All right, so number 2, number 3. All right, so I've assigned my priority, and now I need to get the least important away from me. Now, in this case, it already is away from me, so I'm just going to look at the rotation of those groups. So 1, 2, 3, that is going clockwise. Okay, and another way to kind of remember that is if you draw the R, okay, that is clockwise, and the S isn't so beautiful, but if you're going counterclockwise. All right, so this one is going in the clockwise direction, and the lowest priority is away from me, so this designation is R. So I'm going to put those pieces together, and the stereocenter is, now this is nomenclature, 1, 2, 3, 4. So my parent is butane. What's attached to my butane is a chloro, and where is it attached? This is 2-chlorobutane, but it has a stereocenter, so we need to say where that stereocenter is and what it is. Now, because there's only one, generally we just put R2-chlorobutane because there's only one stereocenter, so it's hard to mess it up. But when you have multiples, there's nothing wrong with saying 2R2-chlorobutane. This is kind of overkill though, if there's only one stereocenter. All right, I'm going to show you the shortcut. So I'm going to do this same molecule, only this time I'm going to put the chlorine away from me, and I'm going to put the hydrogen towards me. So again, this is still number 1, this is number 2, this is number 3, and that is number 4. All right, the least important is pointing right at me. Okay, so the shortcut is it has to be at, okay, or directly facing me. If that's true, just switch the letters. All right, so let's see what that means. So I'm seeing 1, 2, 3. So again, I'm seeing R, but the least important is coming at me. And so it's not going to be R. We're going to change it to S. And so the name of this one is S2-chlorobutane. Now beware, the shortcut, it has to be right at you, and the regular way, it has to be completely away from you. And if you don't want to redraw, you can of course move your body and put it into, some kind of perception of one of those two variations. All right, so let's just do another one here. We're going to do 2 stereocenters this time. Let's see, let's do a bromine right there. Ooh, let's do an alcohol. All right, before I do any stereoisomer designation, let's actually just come up with a name. Okay, so this is just regular nomenclature. The most important functional group is the alcohol. So the longest chain has to include that alcohol. So it's 1, 2, 3, and 4. So the bromine is on carbon 3. The hydroxyl group is on 2. The most important functional group is an alcohol. So this is going to be named butanol. And you have to tell me where the butanol is. So the ol is on carbon number 2. And then tell me what's attached. So this is 3-bromo. Okay, so that's 3-bromobutanol. That's just the regular name. Now let's put the stereochemistry into it. Whoops, too many. All right, there's my OH. There's my Br. Now remember, this is carbon 1, carbon 2, carbon 3, and carbon 4. So we're going to look at carbon 2 right now. So don't forget that hydrogen, and luckily that hydrogen's where it's supposed to be. All right, I'm seeing an oxygen. I'm seeing a hydrogen. I'm seeing a CH3. And then I'm seeing a CHBr, CH3. All right, these are the only ones I'm looking at right now. So the one with the biggest atomic number, of course, is oxygen. So that's going to be number 1. The smallest is hydrogen. And then I can't tell between these 2 carbons yet. So I'm going to go 1 further out. And now I'm looking here, and I'm looking at those 2. And of course, the hydrogens are going to be last. So this one should be number 2, and this one should be number 3. All right, now you might be thinking, wait a second, bromine is further down on the periodic table than the oxygen. First point of difference. Okay, don't go jumping out to the outside. You have to baby step your way away from the stereocenter, and it's the first point of difference. So really, I'm looking at a carbon, the oxygen, and the hydrogen. Okay, don't go any further than that unless you have to. All right, so let me see. Oxygen's number 1, and hydrogen is number 4. This one is number 3, and this one is number 2. All right, the hydrogen is where it's supposed to be. So the others are going that direction, so that is counterclockwise. So this is S3 bromo, and you can put the 2 in, butan 2 all, or remember it is okay. Oh, and I did that too far. It is okay if it can't be confused with anybody else. You may bring it right there like I did up there. But either of those 2 names are correct. And again, you don't have to put the number right there because there's only one stereo center so far. So far. Okay, so I'm going back to my molecule. Oh, look, there are 2 different stereo centers. So I'm going to make a note to myself. This was carbon 2, so it's 2s. That's why I have to put the 2. And when I do the next one, I'll have to put its location so that we don't get them messed up. All right, so now I'm looking at the other side, and I'm going to draw it again just so it's not all gummed up. All right, so the bromine should be number 1. The hydrogen is where it's supposed to be. The carbon and a carbon. So I can choose between bromine, hydrogen, carbon, and carbon. So bromine's number 1, hydrogen is number 4. This carbon right here only has hydrogens, where this one has a carbon and an oxygen, so it's going to get number 2. That one will get number 3. The hydrogen's where it belongs. So that one is R. Now, what number is this? Okay, very, very, very important. The number that goes in front of the letter comes from the actual name. Okay, it has nothing to do with the 1, 2, 3 priority. It is actually part of the name. And so that is carbon 3. And so 3R. All right, so if I go up here, put them in numeric order, this is 2s, 3R, 3 bromo, butan 2 all, or 2s, 3r, 3 bromo, 2 butanol. If you have more than one stereo center, you have to put the numbering system. All right, that is how you would name any of your stereoisomers. And I'm trying to think, is there another one we should do? So we've done 2 stereo centers. Oh, yep, there is one more thing I want to point out. This molecule we've seen in the past is achiral because it has a plane of symmetry. That has nothing to do with the name. There are 2 stereo centers, and so I have to still put the R's and S's in the name, even if it is achiral, okay? You have to put an R and an S if you have a stereo center, regardless of whether it's chiral or achiral. So this one is a little bit interesting because I could say 1, 2, 3, 4, 5, or I could go the other direction and go 1, 2, 3, 4, 5, but luckily in this case it doesn't matter whatsoever. All right, my hydrogens are both behind. All right, so I'm looking at carbon number 2, so fluorine is number 1. This direction would be number 2. This direction would be number 3, and my hydrogen is dead last, so this one is going clockwise. So make a little note to myself, that's 2R. On this side, the fluorine is number 1, this direction is number 2, and this direction is number 3, and this side is going counterclockwise. So it's 4s. All right, so there's the stereochemistry. And then let's name the whole thing. The most important functional group technically is the alkane because the halogens are always substituents. But I have a halogen on 2 and a halogen on 4. They happen to be the same. So we're going to say 2R, 4S, 2, 4, difluoro, and 1, 2, 3, 4, 5, pentane. Yes, I know it's achiral, but you still have to put that in the name. Other words, I won't know which one to draw. All right, so in a nutshell, that is how you name or you complete the name for any stereoisomers as far as enantiomers and diastereomers are concerned. All right, until next time, jolly out.